Hello students. Today I am going to teach you about the memory configuration of microprocessor 8085 program. Before we go into the memory configuration, let us note that there are three types of instruction based on the size of the instruction. So if the instruction, if the instruction has only registers, instruction comprises of two parts. One is opcode, the second one is operand. If the instruction has only registers as operands, it requires only 1 byte of memory. Hence it is called a 1 byte instruction. And remember that in microprocessor 8085, each memory location can store only 8 bit of data, that is 1 byte of data. So basically, to store an instruction which has register as operands, we require one memory location. Now, consider an instruction with register and data, that is data is given in the instruction itself as operands. Such an instruction requires 2 bytes of storage and hence it is called 2 byte instruction. Since it requires 2 byte, it requires 2 memory location, as each memory location can store only 1 byte of data. The third type of instruction has address as operand. So whenever it has an address as operand, it requires 3 byte storage. It's called a 3 byte instruction because it requires 3 memory locations as storage. One for the opcode and 2 memory location to store the memory address specified. Here in this example, I've got a program to add n decimal numbers. It is a program to add n decimal numbers. I'm not going to explain the program down here. I'm just going to tell you how to do the memory configuration. Okay, so for this, let me just get on down there. So here I have a program. So here basically I will just put the address, okay, address, the instruction, where am I going to store the address, instruction, and then I'm going to have the hex code. So here in microprocessor 8085, you will be provided a opcode table using which you are going to configure the hex codes. So let me start with the address. See, you can start with any address you want. Here I am going to start with the address 8000. I am going to start to store the program from the address 8000. So let me start with the address 8000. And what is the first instruction? The first instruction is XRAA. It is XRAA. So the first instruction is XRAA. So here I'll have one more called label, right? Label. So here I'll have the first instruction which is XRAA. So this is the instruction. So what are in this instruction, what are the operands? This is the opcode. XRA is the opcode, A is the operand. So what is the operand? Operand is a register. It's a register. So here we have only registers as operands. So size of this instruction is 1 byte. It requires 1 memory address to store the instruction. So this is a 1 byte instruction and it can be held in the memory address 8000. Now come to the opcode table. I've got the opcode table here. I hope you can all see the opcode table here, right? So I've got the opcode table here. I have to find the hex code of XRAA. So now I go down the opcode table, right? I have to go and find the hex code for XRAA. XRAA. So I'm coming down. I've still not come across XRA. Down again, I'm just coming. If you just go through the table, at one point you will have, can you see here XRAA. Can you see here XRAA? The corresponding hex code is AF and the number of bytes for the equation is 1 byte. So XRAA, the hex code is AF. It is AF. So I take that and come and write here. The hex code here is AF. It is AF. Now done. So now the hex code, it is 1 byte instruction. It is stored in 8000. What is the next address? The next address is 8001. So 8001, what is the next instruction? Next instruction is MVI move immediate D, 0AH. 0AH. I am moving the hexadecimal number 08 to the register D. It is move immediate. What is immediate? Immediate means the data is present in the instruction itself. The data is 0A is present in the instruction itself. So what are the operands in this instruction? You have a register and data. Register and data. So this instruction size is 2 bytes. It requires 2 memory locations to store the particular instruction MVI D, 0AH. The first location is 8001 and 8002. The 2 locations will be required to store this instruction. So this instruction requires 2 memory addresses. It's a 2 byte instruction. Now I have to go and find the opcode of MVID. This is stored in the first memory location. So let me go and find the opcode for MVID. So let me go. I have got here. So the opcode sheet I've got here. So MVID. I'm going here. If you see here, I have got MVID, data. So the opcode corresponding to that is 16. It is 16. Hex code is 16. So here MVID, it is 16 and it's a 2 byte instruction. Can you see here? It's a 2 byte instruction. So 16. The hex code here is 16. So now I have the hex code for MVID, but I have known that this instruction basically requires 2 bytes. 1 byte for the opcode. The second byte is for the data. So the data has to be stored in the next address 8002. You got to store the data. Data is 0A. So basically the instruction MVID, 0A requires 2 bytes. It's a 2 byte instruction. It requires 2 memory location 8001 and 8002. Now coming to the next instruction, which is MVI C, 00. So the next instruction is automatically stored in the next location. It is MVI C, 00. So what type of instruction this is? This is an immediate instruction. And what is the size? Size is 2 bytes because it has data in the instruction itself. So again I go to the opcode sheet. I look in for MVIC. MVIC, if you see, data, it is 0E. The hex code here is 0E. So now for MVIC, I write the hex code, which is 0E, right? And still I've got the data to be written. The data has to be written. So now I've got MVIC, which is 0E. Still data is pending, which occupies the next location 8004. In 8004, I'll be placing the data, which is 000. H is for hexadecimal. Please note that here this H stands for hexadecimal representation. Now what is the next statement? Next statement comes in the location 8005. Next statement is LXI, right, LXI H comma 8500. Load HL with the address specified, right? Here load immediate the HL pair with the address specified. This command is nothing but it is going to load the HL with the address specified. Here of course you have an address. Whenever there is an address in the operand, close your eyes and just know that the instruction size is 3 bytes. The size of the instruction is 3 bytes. Therefore, it is going to occupy 3 memory locations: 8005, 8006 and 8007. So let me go to the table and find the opcode or hex code for LXIH. Right? Let me go to the table and let me find the hex code for LXI. I think it will be up there. LXIH, can you see there? LXIH, which is 21. Here you have got 21. It's 21. LXIH is 21. So once I know that, I write the code, hex code 21. Done. Hex code 21 is written. The next 2 addresses are used to store the address in the instruction. What is the address? I have the address 8500. So in the next location, store the low order bytes. Store the low order byte. What is the low order byte? 00. So the next location, store the low order byte of the address. So low order byte is 00. And in the next location, 8007, store the high order byte, which is 85. So basically this instruction requires 3 memory location. The first memory location, you store the hex code. In the second memory location you store 00. Right, that's the low order memory address, and then you store the high order bytes 85. Okay, 00 and then 85. Now next address 8008. In this address I'm going to have the next statement. Next statement has a label. So I will put the label here. Guys, it has a label. So I'll put the label here. Loop. Right? Label. And then I have ADCM. So here label specifies the address. In this label is nothing but the address 8008. So here you see that you have ADCM. What is the operand here? Operand is memory pointer. So memory pointer is also considered here like a register. So here ADCM requires 1 byte of storage. 1 byte of storage. So you go to the table and you just check for ADC. Right? You just check for ADCM. ADCM. Can you see ADCM, which is 8E? ADCM is 8E. So put here 8E. Right? ADCM is 8E. You have to note only for this. This loop is there because later we are going to direct to this address. So forget about this loop. Just write the loop here so that it will indicate this address. You have to find the configuration for ADCM, the instruction, not the label. Not the label. Okay, so ADCM is 8E. Come to the next address, which is a 1 byte instruction. Done. So it is 8009. Next address. The instruction is DAA, decimal adjust accumulator. So here the operand is basically accumulator, and it is implied that the data is in the accumulator because decimal adjust accumulator. Okay, so here we go again to the table and find the this for DAA. Can you see here DAA, which is 27? It is 27. So here I come again, right? This is actually the opcode table for 8085. So here I just come for DAA, which is 27. So I've got the DAA. So now I come here and write. It's a 1 byte instruction because it doesn't have any address and neither doesn't have a data. It is a implied statement wherein all the operations happen in the accumulator. It is 27. It is 27. So I have just done that. Done. Next statement. Next statement is 80. See, I have come here. This is hexadecimal representation of the address. In a hexadecimal number, after 9, you don't have 10, but you have A. So after 9, it is A. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A. Address here, everything in microprocessor 8085 is represented as a hexadecimal number. So after 9, it is A. So now you have A, 800A. The instruction here is JNC next. Next is a label. Label means address. Label means address. So next is a label. Label means address. But at this point, do we have next here in the label part? No, we don't have a next here in the label part. I don't know what address is for next. So what I will do is, I will configure for JNC and I will leave two memory locations to enter the address later. So what is the opcode for JNC? JNC opcode. JNC. Can you see here? JNC label. It is D2. It is D2. So JNC label, it is basically D2. And I don't know the address now. I don't know the address now. And I also know that address takes two memory location. So later, when I come to know the address, I will fill in the memory locations. Now I will leave the memory locations for later usage. So 800B and 800C are left for later filling up. We will fill up the address of next later when we get the address of next. Right? What is the next statement? It is 800D. So what is the next statement? Next statement is INR. INRC. It is INRC. So what operand we have here? The operand we have here is register only. So it is 1 byte only. Go and get the memory, hex code. INR. It is INRC. INRC. So INRC, can you see here? Which is 0C. It is 0C. So INRC is basically 0C. So write 0C here. Right? Next statement. What is the next statement? Next statement is INXH, and here I have a label next. So first I will write here 800E, which is I have a label here next. Right? And I have INXH. Again here we have only register. So we will go and check the INXH. Can you see here? INXH, which is 23. The hex code is 23. So here I'll go and say 23. But when you come here, you see here next, right? I told you this next is nothing but this address of the particular statement. So what is the address? Address of this statement is 800E. So if jump no carry next, jump no carry, jump to the location 800E. Now I have got the address of the label. I've got the address of the label. So now fill here with the address. Address is 800 E. So fill it there with the address. So when you fill the address, we know the lower byte is 0E. So in 800B, write the low order byte. Write low order byte, and 800C, write the high order byte, which is 80. So basically 800E is written in 2 memory location. So done. Next is done. What is the next statement? Next statement is decrement D. DCR D. Decrement D. So that comes in the next memory location 800F, which is decrement DCR D. DCR D. So what is DCR D? Again, I'm going to go and check in the table. So DCR D. Okay. So DCR D. Can you see here? DCR D. The hex code is 15. 15. Right? The hex code is 15. So I'll come here and I'll write the hex code as 15. It's a 1 byte instruction because it has only the register. So only 1 byte, 1 memory location. Next one is nothing but remember here, hexadecimal number goes from 0 to F. After that it is again 1 0. So you have got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, and then you have 8 0, 1 0. Now you go to 8 0, 1 0. What is the next instruction? Which is JNZ loop. This instruction is JNZ loop. Right? So here you have JNZ loop. What is the address of loop? Of course we know. Loop is the label. The corresponding address is 8008. So we have got the address also, which is 8008. So now we go and check the hex code for JNZ, and of course because it has an address, wherever label is there it means address. Therefore the instruction is a 3 byte instruction. This instruction is 3 byte. So in that case we have to go and check the hex code for JNZ, and the next 2 memory locations will be for 8008. So now let us go and check for JNZ. So if you have see here JNZ label. JNZ label is C2. It is C2. So come here, right here C2. It is C2. Enter. Next location is 8011. So here again I have just given the hex code for JNZ. Still the address is pending. So now the next comes a low order byte. Low order byte is 08. Put there 08, and then in 8012 comes the high order byte, which is 80. Right? Next, what is the thing? Next is, what is the instruction next? After JNZ loop, move L comma A. Move L comma A. So here, next address 8013. I have the next instruction, which is move L comma A. Here if you see, both are registers. The operands are registers. So it is a 1 byte instruction. It takes only 1 memory location. Go there. Check for move. Check for move. I think it will be above or below. Move L comma A. Move. Can you see here? Move L comma A. Move L comma A. So here it is 6F. The hex code is 6F. So coming back here, we put the hex code. Hex code is 6F. 6F. Right? It is 6F. And then you have 8014. The next instruction, which is move. Move H comma C. H comma C. So here again move H comma C. Both are registers. So 1 byte. So go again back to the thing. Move H comma C. Can you see here? Move H comma C, which is 61. The hex code is 61. So here I come back here. I put the hex code as 61. 61. and then I do the next instruction 8015. In 15 I have SHLD 8600. It is store HL direct. Store HL direct 8600. It is hexadecimal representation, so I have a H there. So here store HL direct, I have an address. Whenever there is an address in the instruction, close your eyes, 3 bytes. So first we have to go and find for SHLD. Next two addresses, it is 8600. So now I'll go here. I'll just go and find the code for SHLD. Is it down there? Yes, can you see here? SHLD, which is 22. The hex code is 22. So here I put 22. I'm storing the HL direct, which is 22. Next I have two address. 8600 should be stored. The address has to be stored. So 8016, I store the low order byte, which is 00. Low order byte is 00. In 8017, I store the high order byte, which is 86. It is 86. So 8600, the address 8600 is stored this way. First low order byte, then the high order byte. Then the last statement is halt. So now the last statement I'll put in the memory location 8018, which is halt. So halt, the corresponding hex code is 76. Hex code for halt is 76. It again has no operand, so of course it is a single byte instruction 76. So this way, for mnemonic codes, you can get the corresponding hex codes and configure the memory address. So you can start at any memory address, but remember, memory address are represented in hexadecimal codes. I am starting here at 8000 and I am configuring the address for each instruction, and instruction size will be either 1 byte, 2 byte or 3 byte. If it has only registers, it is 1 byte. Immediate data 2 bytes. So in the immediate data case, you use, first byte is for the opcode, second byte is for the data. This is the data. And in case of address, first byte is for the opcode, next 2 bytes are for the address. First is the low order address, the next is the high order address, 00 then 85. So this way you configure the memory